Hey there, ho there, how do you do? Well, if you know what section that is, or what movie that quote is from, let me know next time you see me. But anyway, we're gonna go with section 7.5 today. This is about rational exponents and radicals. So we've been working on a chapter with a lot of exponents. So today's learning target is going to focus on rewriting expressions involving radicals and rational exponents. All right. So the only vocab we have today, the only terms that we're going to focus on are these three: index, radical sign, and radicand. So if you did not know, the radical sign is the square root sign. So in other words, the square root sign, that would be this one right here. All right, the radicand is whatever is underneath the radical sign. And then sometimes, and this is a little bit of a review, sometimes there's a different number up on that radical sign. So if there's no number, it's just the square root. But if there's a different number, that means you're trying to find a different, how many times, or a number that goes into it, however many times. That's called the index. So we're going to do some examples with different index numbers. So, quick review, finding roots. So what is the simplified form of each expression? This one on the left is the cube root. So the index is 3. That means you're trying to find what number times itself 3 times gets you to 125. And that actually is going to be 5. Because 5 times 5 is 25. So there's the hint. What number times itself 3 times gives me 125. The one over on the right says the fourth root of 16. So that's what number times itself 4 times gives me 16. So that would be equal to 2. Alright? And that would be because 2 times itself 4 times equals 16. And over on the left side is 5 times 5 is 25 times 5 is 125. Alright? So some of these are easy to memorize, some of these are easy to figure out, but there's another way. You can always use your calculator. Um, so I've got a little calculator off to the side. Um, Here's how you find it if you're using a calculator. This is a typical calculator. Um, First, push the index number. So if you're doing the cube root, you want to do 3. First, put in 3. And then the second button, because we're going to use the square root symbol, and it's the exponent key. All right, so it's this one right here. Um, that would show up as the radicand. All right, and then you can put in the number. So which is the radicand? Sorry, that would be the radical symbol. Then you put in the radicand, which would be 125. 125, and you can hit equal. That'll give you the answer for a radical if it's not a square root. If you want to just do a square root, you just have to do second and then the little caret symbol here. Because that'll give you just a regular square root. But to do it with a different number other than a square root, you have to put in that index number first, and then do second and the exponent symbol. And then you put in your number and hit enter. Okay? So in case you didn't know that. Alright, your turn. You can use a calculator or you can do it on your own. I'd like you to try these 4, or at least 1, 2, 3 of them. We have the cube root of 27, the fifth root of 32, the cube root of 64, and the square root of 36. I'll put those answers up in just a sec. You can pause it and try those. Alright, there's the answers for each one, and the work below it to show you why it is what it is. Now, moving on from there, here's a key concept for today. If the nth root of a real number is m, and n, um, if the nth root of a is a real number and m and n are positive integers, then okay, so this is the first part. If you have a fraction, that would be the exponent. That's the nth root. It's 1 over a number. That's the same thing as taking the nth root of that. So we'll give some examples. Same thing as this. This will be a little bit more challenging when we have something other than 1 on the top. But the number on the bottom is still going to be that nth root, but then inside the radicand is raised to the power of the m. So let's look at examples, because that'll show it a lot easier. So converting radical form. Simplified expression 81 to the 1/4 power. So In other words, we need to find the number that when multiplied by itself 4 times, it gives you 81. Now, that would be the same thing, based on what we just saw, as the fourth root of 81. Okay, it's 1 over 4, so it's the fourth root of 81. And we finally get the answer, and there should be dots here, of 3, because 3 times itself 4 times gets you to 81. Okay? Now, if a number or variable in an expression does not contain a fractional exponent, you do not have to write that portion in radical form. So, we're going to do two things here. We're going to switch it up a little bit, and we're going to look at one where the exponent does not touch both parts of it. Okay? So here's the example. We have 12 times a to the 2/3 power. So the 2/3 is just raised to the a. So we have 12 times, that would be 12 times the cube root of a squared. And that's the answer. Because of that rule that we said at the key concept. 12 is just out in front, so it's not attached. But the a squared, or a to the 2/3 power, is the same thing as the cube root of a, because you take that as the cube root, the bottom number, and the 2 goes with the a then. It's a squared. Okay, that's a way to write that in radical form. Here's another example. Now it's all inside of the parentheses, so it's all part of the fraction. So we have to, like we've learned, we have to distribute to both of those. So before we do that, though, to make this easier on ourselves, we're going to change um, 32 so that it is an exponent. Okay? 32 would be the same thing as 2 to the 5th power. And then when you do that times 4 over 5, so that would be 5 over 1 times 4 over 5. Remember, that's our exponent. Then we still have times a to the 4/5 power. Um, if you look at this, 5 on top cancels out with the 5 on the bottom. So really, that's just 2 to the 4 over 1 power, or 2 to the 4th power, times a to the 4/5 power. 2 to the 4th power is 32. No, sorry, not 2 times 2 is 4 times 2 is 8. 16, so it's 16. And then a to the 4/5 power would be the 5th root of a to the 4th power. Okay? So, we could have done the same thing with the 32. We didn't have to break it apart. We could have done, um, I'm going to pull this out here. We'll do this right here. This part right here, we could have done 32 to the 4/5 power, which would be the 5th root of 32 to the 4th. Alright. We could have done 32 to the 4th power, which we'll get a really big number and take the 5th root. You'd end up getting 16. Okay? I just did it away so you don't have to use a calculator. So now we've done a couple examples. We're going to do one more, and then I'll let you try some on your own. So what is 64a to the 4/5 power? So we're going to first distribute that 64 to both parts. And actually, we're going to break apart 32 into a again. I mean, you can do it both ways. You can use it, so you use your calculator, but we can break it apart because 32 is 2 to the 5th power. So then we get 2 to the 4th power there, times 2a to the 4/5 power. Then we have 2 to the 4th power is 16, and that would be 2a raised to the 4th power, and you take the 5th root of that. Okay? So if you had a hard time following that, go take it step by step. It's actually very similar to the last problem. Um, it's just instead of 32a to the 4/5 power, we have 64a to the 4/5 power. Okay, and again, you could have done this. You could have done 64 to the 4/5 power times a to the 4/5 power. The only thing is, when you do 64 to the 4/5 power, you're going to get a weird number. So it's not going to come out perfectly. So that's why we split it up. And we did, this would be 32 to the 4/5 power times 2 to the 4/5 power. And then we kept the times a to the 4/5 power. We kept these two together. We just made that into the fifth root of 2a to the fourth power. And then this 32 to the 4/5 power, you end up getting 16. So you can do that in a calculator. You can break it down. It's up to you how you want to do that. But I would like you to try at least one of these. I have three of them for you. Oh no, at least one of these. All right. I did give you the answers because I want to see if you can figure out how to do it. All right. I'll give you the answers in a sec. You can pause it if you'd like. All right. So here are the answers. A to the fifth power. The sixth root of a to the fifth power. Second one would be 5 times the x to the cube root of x. And then the last one, you'd have to distribute to both of these. And then when you do that, you get 9. So you can break this one apart to be, so that would be 27 to the 2/3 power times, so if we're taking the 27 out, it'd be 2y then to the 2/3 power. 27 to the 2/3 power, because that is 3 cubed times 2/3 then, which would end up being 3 squared, which is 9. And then this side you'd have 2 to the 2/3 power, which would be, well, really we'd have um, the cube root of 2 squared y squared. But 2 squared is 4, so that's where we get that right there. All right? Now, last thing with this, well, just about the last thing, would be converting to exponential form. So a little bit simpler. Um, Taking what we just did and going backwards. So here's an example. Sorry. What is the fifth root of b cubed? So remember, b cubed, so we have the 3 is going to be on top, and then if it's the fifth power, you're just taking it and you're putting that power underneath. So it's like the fourth power would be 1/4. Sorry, the fourth root would be to the 1/4 power. We're just going to put that underneath the fraction, and we get b to the 3/5. This is going to be the same thing. Oh, we're going to take 27 to the 1/3 power, and then d to the 5/3 power. 27 to the 1/3 power is actually 3, so we're going to have 3 times d to the 5/3 power. Okay? Alright, your turn. Why don't you try that? I have 4 of them here. Try at least 2 of them. Pause it and then play it again. You can see the answers. Alright, there's all your answers. S to the 2/3 power, 12, x to the 4/3 power. This third one you could do it a couple different ways. If you just simplified it, it would be, since there's nothing here, this would be a 2. So it would be all that to the 5/2 power. But if you distribute that, you can simplify it a little bit. And I got 5 squared, which actually, sorry, 2 squared, which actually would be 32 y to the 5/2 power. So get rid of that. I simplified it even further. And then the last one would be 4a squared. Simplifies to that. Because when you get a to the 8 over 4 power, that is 2. 8 over 4 is 2, so it's squared. All right, very last thing. Real world application. You can estimate the metabolic rate of living organisms based on body mass using Kleiber's law. So this is some guy who came up with this formula. The formula is R, so that's the metabolic rate, is 73.3 times the fourth root of m cubed. That formula relates metabolic rate, R, measured in calories per day to body mass, m, measured in kilograms. So what is the metabolic rate of a dog with a body mass of 18 kilograms? So what we do is we plug in 18 for the m, and then we simplify. Okay? I'm just going to say use a calculator. It's a formula, but if you look at it, it's very similar to what we've been doing. You could change that to 73.3 times m to the 3/4 power. That'd be the same thing. And this is actually used in a formula that'll work. So if you're given, so you know how, if you don't know what a metabolic rate is, it just tells you how many calories you burn, or how fast you burn calories, I should say. Um, So, there you go. All right, so calories per day to body mass. So, the metabolic rate would be about 641 calories per day for this dog, just based on his weight. Okay? So, your turn. Using the same formula, what is the metabolic rate of a man with a body mass of 75 kilograms? I know we don't usually use kilograms, but since this one is based on kilograms, we're not going to adjust it right now. So, why don't you pause it, try it, and then check the answer, and we'll finish up. All right, so this is what I got. When I plugged it in, I got about 1,868 calories per day for this average sized man. All right, and that tells you that based on this average size man, your body by itself will burn about a little under 2,000 calories per day. So that's why if you want to maintain your weight, they usually say around for an adult you should be only consuming around 2,000 calories per day. So you can keep it around the same that you would be burning per day. All right. And that obviously changes if you exercise more and you do different things. But that's a great real world application for what we're talking about today with radicals and exponential or rational exponents and radicals. All right. So go back to our learning target. That's what we wanted to get to. Self-assess yourself a little bit on whether you met that or not. And we'll see you next time.